For today's lesson, we will be discussing about the limits of algebraic functions. So in the previous video, we already discussed what is a limit, and we also tried to evaluate the limits of the different functions using the table of values and by graphs. So this time, we will be discussing how to evaluate the limits of algebraic functions. So there are three. First is getting the limit of a polynomial function. Then we have the limit of a rational function. And lastly, limit of a root of a function. So we will be discussing how are we going to evaluate the limits of these three functions, what are the techniques that we can use in order to evaluate them, and what are the things that we have to remember when we are evaluating these kinds of functions. Let's start with limit of a polynomial function. So let's see the element of any real numbers. If p of x is a polynomial function, then we can say that the limit of p of x as x approaches c is equal to p of c. Last time we discussed that limit of p of x is not the same as p of c by definition, because as what we know, limit, this refers to the value that the function approaches as x approaches c, whereas p of c means we're getting the value of the function at this particular value. But of course, there are cases wherein we can apply direct substitution, meaning these two values now will be the same. One of that cases is for polynomial function. As long as p of x or the given function is a polynomial, then we can say that p of c is the same as the limit. So we can just do direct substitution. So let's have an example. Let's say we have to evaluate the limit of x squared plus x minus 5 as x approaches 1. So as you notice, this one, the given function is a polynomial function. Therefore, we can just simply do direct substitution. So let's just write here as x approaches 1. So we can just do direct substitution. So this will be 1 squared plus 1 minus 5. Simplify everything. So 1 plus 1 is 2 minus 5. We have negative 3. So this is now the limit of our function. So that means as the value of x approaches 1, the value of the function or the function approaches negative 3. Again, we can only do direct substitution if first case is that the given function to you is a polynomial. Next is, let's have limit of a rational function. So let's say r of x is a rational function and c is element of the domain of r. Then we can say again that limit of r of x as x approaches c is just the same as r of c. This will only happen if c is element of the domain of our rational function. So if in case that c is the element, we're able to make sure that c is the element of the domain, then we can do again direct substitution. Now, how will you check if c is part of the domain of our rational function? One thing that you can do is by just substituting the value of c to the denominator, and if you notice that it becomes 0, that means c is not part of the domain because it will make your denominator 0, and that means the function itself will become undefined. So that is the time wherein we can say that c is not part of the domain. So we cannot do direct substitution with that. But if in case after we substitute and then the denominator is not equal to 0, then we can proceed with direct substitution because that means c is part of the domain. Let's have this example. Let's say we have to evaluate the limit of 3x plus 2 all over 5x minus 1 as x approaches 2. So again, one thing that we have to do first is to check if the value of c given here is part of the domain of the given function. So in checking, all you have to do is just to substitute c to the denominator. So c is 2 and then the denominator is 5x minus 1. So if we substitute, we are actually getting a value of 9. So that means since this is not equal to 0, 2 is part of the domain. So we can do direct substitution and we can substitute 2 to the whole rational function itself. So let's do it. Limit of 3x plus 2 over 5x minus 1 as x approaches 2. So let's substitute. We have 3 times 2 plus 2 all over 5 times 2 minus 1. And then simplify this. We have here 6 plus 2 is 8, and then 10 minus 1 is 9. So therefore, the limit of the function 3x plus 2 all over 5x minus 1 as x approaches 2 is equal to 8 over 9. And last, let's have the limit of a root of a function. Let n be element of natural numbers, and limit of f of x as x approaches c is equal to L. Then we can say that the limit of the nth root of fx as x approaches c is just the same as getting the nth root of its limit. So here, the only thing that we have to consider is that you can get the f of x, the function, inside the radical symbol, and then you get the limit of that. After you get the limit, then you just have to get the nth root of that limit. Now, the rules in radicals, of course, will be applied or should be applied in this case, which are n is odd. If n is odd, the radicand or our limit can be positive or negative. We're talking about the radicand, this one right here. This one. Okay, so it can be positive or negative as long as n is odd or the index is odd. However, if the index is even, or our n here is even, L should be greater than 0. Because of course, if L is negative and the index is even, then we cannot get the nth root of that. Or, n is even and f of x approaches L equals 0 through positive values. So if L is also 0, then we can still get the nth root of that. So these are just the things that we have to consider. Now let's try this example. Let's say we have to evaluate the limit of square root of 7x plus 1 as x approaches 5. So what we can do is, so let's write here as x approaches 5. You can get first the limit of the function inside the radical sign. So since it's 7x plus 1, that means it is a polynomial. So we can just substitute 5 and then get the square root of it after. So 7 times 5 plus 1. So this will be equal to square root of 35 plus 1. So that's 36, or the answer is 6. So therefore, the limit of the given function square root of 7x plus 1 as x approaches 5 is equal to 6. Now let's evaluate more examples here. Let's try to evaluate the limits of the following. So first one, let's try to evaluate the limit of x cubed plus 2x squared plus 3x minus 8 as x approaches 3. Since in this case, as you can see, the given function to us is just a polynomial. So therefore, we can already get the limit of this by evaluating or by substituting the value of c to our function itself. So what we can do is, let's write here 3 cubed plus 2 3 squared minus 3 times 3 minus 8. And then all we have to do is to simplify this. So we have 27 plus 9 times 2 is 18 minus 9 minus 8. Or if you get the simplified form of this, so we have 28 as our answer. So that means the limit of this function is 28, or the function approaches 28 as the value of x approaches 3. Another example, let's take into consideration this rational function here. And then we have to identify the limit of this function as x approaches 3. Now, since we are dealing with rational function, first, the thing that we have to do is to check if the c is part of the domain. So to do that, we have to substitute first c to the denominator. So we have 3 squared minus 4 times 3 minus 1. So if we simplify this, so that will be 9 minus 12 minus 1, which is just equal to negative 4. Since there is a value, that means 3 is part of the domain of this rational function. So we can do direct substitution. So let's evaluate the whole function. So let me just write here. Let's substitute right away. So we have 3 cubed plus 2 times 3 squared minus 3 times 3 minus 8 all over 3 squared minus 4 times 3 minus 1. And then you simplify the numerator, so that will be 28. And then you divide it by the denominator, which is negative 4. So simplifying this, we will get negative 7. So therefore, our function approaches negative 7 as x approaches 3. So that is, again, what you will do. You check first if the c, or the value of c, is part of the domain of our rational function. Another example. So we have to identify the limit of the given rational function as x approaches negative 1. So let's check if c is part of the domain. So by substituting, so 2 times negative 1 squared minus negative 1 minus 3. Now if you will look at this will be 1 times 2 is 2. 2 plus 1 is 3 minus 3, 0. So if we substitute negative 1 to this rational function, the denominator will be equal to 0. So that means we cannot do direct substitution right away, because if we will do that, the denominator will be equal to 0. So what are we going to do now? Once you know that, or once you identified that c is not part of the domain, or it will make your rational function undefined, next thing that we have to do is to simplify first the given rational function. So how are we going to simplify this? So you can apply different factoring techniques. Find ways on how you can simplify the given rational function. So what we will do is, for the numerator, since it's x cubed plus 2x squared plus x, all of the terms, they have the variable x. So what we can do is, we can just factor out x. And then x times, factor out x to the numerator. So we will have x squared plus 2x plus 1. For the denominator, let's just copy it first. So 2x squared minus x minus 3. Now after we factor out x, observe again the terms that we have. So here, if we will substitute negative 1, nothing will happen. It will still be equal to 0 because we did not do anything to the denominator. So let's continue this one. Aside from factoring out the common monomial factor, we can still factor the trinomials here. So let's factor x squared plus 2x plus 1. So that will be x plus 1 times x plus 1. Then let's do the same thing for the denominator. So the factor of this trinomial will be 2x minus 3 times x plus 1. Now after factoring the numerator and the denominator, you will notice that we can cancel out common factors, which is in this case is x plus 1. So we can cancel this and we will be left with x times x plus 1 all over 2x minus 3. Now if we will check, if we will substitute negative 1 to the denominator, so that will be 2 times negative 1 or negative 2 minus 3, so that will not be equal to 0 anymore. So that means we can now proceed with direct substitution. So that is the technique that you will do if in case you notice that when you do direct substitution, the denominator will be 0. So you have to simplify it first by factoring. So let's now proceed with substitution. So x times x plus 1 all over 2x minus 3 as x approaches negative 1. So let's substitute negative 1 times negative 1 plus 1 all over 2 times negative 1 minus 3. So the numerator will be 0 all over negative 5, which is, if we simplify, is just equal to 0. So that means our function approaches 0 as the x approaches -1. Another example, let's say we have to identify the limit of the function square root of x plus 4 as x approaches 0. So in this case, we just have to look at the function inside the radical symbol. So it's x plus 4, meaning we can just do direct substitution. So square root of 0 plus 4. So this is just equal to square root of 4, or the answer is 2. So you can just do direct substitution if in case it's just like this. There's no restrictions because it's not one-sided limit. But if in case the given is like this, we have to identify now the limit of the square root of x squared minus 5x as x approaches 5. So notice that what we have here is a one-sided limit. We have to get the limit of the function as x approaches 5 from the right. Now, let's say we do direct substitution. If we will do direct substitution to this, let's say we substitute 5 to this function. So that will be 5 squared minus 5 times 5, which is equal to square root of 25 minus 25, or 0. Okay? So if we do direct substitution to this particular function, the value of the limit will be equal to 0. Now, we have to make sure that the limit or the value of the limit is really equal to 0. So how are you going to check? We can identify values from the right of 5, and then let's try to substitute it to this given function. And then let's see if it will really approach 0. So what are the values on the right side of 5? So actually we can just get 5.0001, or let's write 5.0001, 5.00001. Okay, you can try any values, and then let's see at what value will our function approach if we will use this particular values. So if we substitute 5.001 to our function, so the function or the value of the function will become 0.0707. Okay, if we substitute 5.0001, our function will become 0.0223. And lastly, if we do it 5.00001, our function will become 0.0070. So as you notice, as the value of x gets closer and closer to 5, the values of the function is getting closer also to 0. So that means our answer here is correct because they are the same. So we can do direct substitution to this, since after we consider the values on the right side of x, which is 5, we're still able to get 0 as the limit of our function. How about if we have this particular example? We have to get the limit of square root of x squared minus 4x as x approaches 4 from the left. So what will happen if we will do direct substitution? So let's try to do direct substitution here. Square root of, then we have 4. So 4 squared minus 4 times 2. Let's see what value are we going to get. Square root of 16 minus 16. So this will be equal to 0. So if we do direct substitution, the value of the limit is equal to 0. Now, we have to know if this is really true or valid, that the value of our function, or the value that our function approaches as x approaches 4 from the left, is really equal to 0. So how are we going to check? Let's do the same thing like what we did on the previous example. Let's try to get values that are closest to 4 from the left. So what are those values? We can try 3.990, 3.995, and 3.999. Now, let's observe the values. What will be the values of the function if we will substitute it to this function? Okay, so let's try it with 3.990. So if we will be getting square of 3.990 minus 4 times 3.990. So the value inside the radical symbol will become negative 0.0399. And as what we know, if the radicand is negative, that means we cannot get the square root of that. So there is no value for this. If we will do it also for the rest of the numbers, so it will be the same. So we will be getting a negative value for the radicand. So for the next one, this one will become a square root of negative 0.0199. And then for the 3.999, it will become square root of negative 0.0039. So, since the radicand is now negative and we have to get the square root of that, that means we cannot get a value for this. So this means now, since we cannot get any value if we really substitute the values from the left to 4, this means that the limit does not exist. Okay, so it's not true that the limit is equal to 0. So in this case, we cannot use direct substitution because you really have to check if the value that you will get here will be the same as if we do direct substitution. But since they are not the same, so actually we're not able to get the values as we substitute those numbers from the left to 4. So that means the limit does not exist. So just remember, if you want to get the limit of a function and then it's a one-sided limit, so you really have to consider or check first and not do direct substitution right away. And for our last example, let's say we want to get the limit of this given function, 3 minus the square root of x plus 10 all over x plus 1 as x approaches negative 1. So this is in fraction form, so we have to check if the denominator will become 0 if we substitute negative 1. Obviously, since x is equal to negative 1 or the c is equal to negative 1, if we substitute it to the denominator, it will become 0. Now, we cannot do direct substitution because of that. So we have to find ways how are we going to simplify this. Notice or look at the terms that we have. So obviously, we cannot factor. We cannot do anything about it. We cannot factor it because the terms are not factorable. So, if in case the terms are not factorable, one thing that we can do is by using conjugates. Let me just write here the function. Square root of x plus 10 all over x plus 1. So, another technique that we can do is by using conjugates. So, we can multiply this whole function by its conjugate. So, how are we going to identify the conjugate? If in case there is something like this, there is a square root in the fraction, so we will be considering that one. Since the square root is on the numerator, so we will be getting the conjugate of the term in the numerator. What do we mean by conjugate? We are just going to copy the terms, but we are changing the sign. So we will multiply to the conjugate of the numerator, which is 3 plus square root of x plus 10. So we will multiply both the numerator and the denominator by this. So by multiplying the conjugate to the whole function, we can now simplify this. Again, how are you going to choose which one will you use? So the one with the square root. Okay? So most of the time, terms with the square root, that is the one that we will consider for getting the conjugates of our function. So multiplying this, the numerator here will become, you can If you want, you can do FOIL method. You multiply this one by one. Or since they are just the same terms, then different signs, so that means we can just write it as square of binomial. So you square this, so that will be 9. And then the sign will be negative. And then square also the second term. So square of square root of x plus 10. So that will just be x plus 10. What happened here is you just square the first term, which is equal to 9. And then we also square the second term, which is x plus 10. So that will be x plus 10. So 9 is this one, and then x plus 10. And then the operation is subtraction. For the denominator, you don't need to really multiply all of them. So just write them as factors. X plus 1 times 3 plus square root of x plus 10. Then we can simplify the numerator. So 9 minus x plus 10, we can distribute negative. So 9 minus x minus 10 all over x plus 1 times 3 plus square root of x plus 10. So let's simplify first the numerator. So this will become 9 minus x minus 10. You can subtract 9 and 10. So that will be negative x minus 1 all over x plus 1 times 3 plus square root of x plus 10. Now, what are we going to do next here? So, if you will observe, we have here x plus 1. The numerator, it's negative x minus 1. So, we want something, or we want to cancel something here. So, what you can do is, you can go again to the numerator and then factor out the negative. So, it will become negative times negative 1 here, negative times x, and then the negative here will become plus 1. Okay? So, we just factor out negative 1. They are just the same. If you distribute this, negative x minus 1. So, it will be just the same as this. So that we can cancel out the x plus 1 on the denominator. So, we can now cancel this. And we will be left with, so this will now be negative 1 all over 3 plus square root of x plus 10. Now, you can check after you substitute negative 1 to this, so the denominator now will not be equal to 0. So that means we can now proceed with substitution. So let's just substitute. So we are now getting the limit of the new function, which is negative 1 over 3 plus the square root of x plus 10 as x approaches negative 1. So we can now substitute. So we have negative 1 all over 3 plus the square root of negative 1 plus 10. So this is just equal to negative 1 all over 3 plus square root of 9. Negative 1 over 3 plus 3. Or this will now be negative 1 over 6. So that will now be the limit of the said function. Again, what we did here is, since we cannot factor the given functions, what we did is we use conjugates. So when we say we are using conjugates, that means we're just getting the same terms from either the numerator or denominator, but with different signs. We choose the numerator in this case because we want to remove the square root. Okay, so we have to multiply it by its conjugate. And then you simplify, and then we will arrive at this answer, which is negative 1 over 6. One thing that we can also add is that if you notice that if you substitute negative 1 to the whole function on the original one, so this will become 3 minus square root of negative 1 plus 10 all over negative 1 plus 1. If you simplify this, this will be 3 minus 3 all over negative 1 plus 1, or 0 over 0, which becomes indeterminate. Okay, so if the function becomes indeterminate after substituting c So that means we have to use conjugates. Okay, so that is also one of the clues that you can use, whether you have to use the conjugate or not. So if it happens that when you substitute the value of c to the original function and it's 0 over 0, or if it's indeterminate, then that means you will be using conjugates. So that's it for today. I hope you learned something about how to evaluate limits of algebraic functions, what are the different techniques that we can use when we evaluate algebraic functions, and see you next time.